So we've got 2x over x minus 7 minus 19 over x plus 4 equals 154 over x squared minus 3x minus 28. So remember, when you have more than just a fraction equal to a fraction, what we want to do is we want to find the least common denominator. But if you look at our problem right here, we've got three different kind of polynomials in our denominator. Before we go and find the common denominator, the best thing to do is to take this guy who's a quadratic and factor him. And let me tell you what, because math teachers are usually pretty nice, most of the time, that's going to factor to whatever these two guys are. And you can see in this case, that's what's happening here. So I'm just going to cross this out and replace it with the x minus 7x plus 4. It's a little bit of space saving for me, and it's the same problem. Now that I've got this, what is my common denominator? Well, it looks like the common denominator will be 1x minus 7 and 1x plus 4, because that's the most number of each of those that I see appearing in any one of the fractions. And now let's remember, what do we do with that common denominator? In our class, it's silly, but when we multiply both sides of the equation by the common denominator, where does that common denominator end up? Since we're multiplying, we're going to put it in the numerator. So we're going to have 2x over x minus 7 is our first rational, and that's going to get multiplied by x minus 7x plus 4. Our second rational is a minus 19, so we're going to put a minus sign here. We'll put the 19, and then we'll have x plus 4. And we'll multiply it by the common denominator, x minus 7, x plus 4. And this is equal to 154 over x minus 7, x plus 4. And again, you have to multiply every single fraction. That's what happens when we distribute this and multiply by both sides. So both sides will get multiplied by x minus 7, x plus 4. Now, if we've done this correctly, what we will notice is that, oh, look, the first fraction, there's an x minus 7 in the numerator and denominator. Those will cancel or divide out. In the second fraction, numerator and denominator, those will cancel. And in the third fraction, both the x minus 7 and the x plus 4 will cancel. So what do we have left when we are done with all of this? Well, looks like we'll have a 2x times x plus 4 minus 19 times x minus 7 is equal to 154. And again, what I love about these problems is they look really ugly for a second, but then this is pretty. Like, this is a normal kind of question that we will be able to solve. So we're going to go ahead and keep going. We'll distribute our 2x and collect like terms and get everything on one side. Let's see, 19 times 7 is 133. And I'm going to go ahead and subtract the 154 over to the left-hand side and collect like terms. So we get 2x squared minus 11x minus 21 is equal to 0. We'll go ahead and factor this. So what two numbers multiply to 2? 2x and 1x multiplied to 2x squared. What two numbers multiply to negative 21? Well, a negative 7 and a positive 3. We'll check our OI. We have 3x minus 14x is negative 11, which is what we have in the center here. So this is correctly factored. Now, what are the two answers when we set 2x plus 3 equal to 0? That gives us x equals negative 3 halves. And when we set x minus 7 equal to 0, we get x is equal to 7. So many students are like, yes, we've done it. We're going to plug this in and to MyOpenMath, and this is our final answer, and we're really excited. The problem is that if you plug this at negative 3 halves and 7 in to MyOpenMath, it's going to tell you you're wrong. And there's a reason for that. This answer at this moment is in fact wrong. Why is it wrong? Well, remember, the worst thing you can do in math is divide by 0. Dividing by 0 does not exist, right? The other thing we always got to remember is that anytime you start with an x in a denominator or an x under a square root, you have to check your answers. So we're going to call these two numbers our candidate answers. -3/2. If I plug -3/2 into x minus 7, do I get a 0 in a denominator? No. If I plug -3/2 into the original equation where there's an x plus 4, do I get a 0 in the denominator? No. So that question is actually a good, or that answer is actually a good and answer, and we can keep it as one of our solutions. But what happens when I plug 7 into this first fraction? I get 2 times 7 over 7 minus 7, which is 14 divided by 0. Is that allowed? Are we allowed to divide by 0? No. So this is what we call an extraneous answer. It looks like an answer, but when we try to plug it back into the original question in for all the x's to see if it's actually a legitimate solution, it is not one. So with all of these rational questions, you must, after you get to this answer, you must go back and ask, does this make me divide by 0? Yes or no? If the answer is yes, then you have to throw that answer out. So our final answer here is just x equals